Hi, my name is Abdul Halim Iqmal bin Kadir. So today, me and my friend will present the application of differentiation rate. There is my group member that me and my friend are group 3 and my member's name Najat Shasha Nordin. Let's go on to the introduction relate rate. In differential calculus, relate rate problem involve finding a rate at which a quantity changed by relating that quantity to other quantities whose rate of change are known. The rate of change is usually with respect to time. There is the procedure for solving a relate rate problem. First step is identify the rate of change that are known and the rate of change that is to be found. Interpret each rate as a derivative of a variable with respect to time and provide a description of each variable involved. For the next step, find a formula or equation that relates the variable in step 1. In a geometric problem, this is aided by drawing an appropriate label figure that illustrates a relationship involving this variable. For the next step, differentiate the question. You will usually differentiate implicitly with respect to time. For the next step, evaluate the equation found in step 3 using the known value for the quantities and their rates of change at the moment in the question. For the last step, solve for the value of the remaining rate of change at this moment. So now, let me see the calculation from my friend.
We are going to present on how to solve related rates problems. In this video, we will show on what are the related rates problems at 30 seconds, then 5 steps to solve related rates problems at 1 minute and 50 seconds, and then example related rates problems at 3 minutes and 50 seconds. What are the related rates problems? The solution is a rate of change. Its given information will include a rate that is related to what you are trying to find. It also requires calculus, of course, and with respect to time to solve related rates problems. And in a minute, we'll talk about a rocket being launched. And if you know the rate at which the rocket will be rising, and then we can find the distance from the observer, between the rocket and the observer. There are 5 steps on how to solve related rates problems, in which are, firstly, we need to draw a diagram. This is needed because we need to know the visualize of how it would look like. To calculate, and secondly, label all quantities and the rates of change. So important because we need to know if it's in second, hour, or minutes. And thirdly, relate all quantities in the same equation, because in order to find the answer, we need to use the same formula. Fourth, differentiate the equation with respect to time. We will differentiate the equation with respect to time. And then, this is the last one, use the resulting equation to answer the question. Also, based on the question given, and also the context, in order to find the final answer. So the answer from the equation respect to time will be used. Here's an example problem for related rates. You're observing a rocket launch from an observation post 5,000 meters from the launch pad. When it reaches an altitude of 10,000 meters, it is traveling at a rate of 200 meters per second. How fast is the rocket moving away from you at this moment? That's the question given for you to find out. So let's find out on how fast is the rocket moving away from you at this moment? Firstly, draw a diagram, which is the first step. So let's say this is you, and this is the launch pad that is away from you, and I draw there's a square, and also this is the rocket that's launched from the launch pad, and this dotted line represents the distance from the rocket moving away from you, the distance between you and the rocket that is moving away. But you don't have to draw this like this, you can also draw it like this, straight line with the units, and put the launch pad, also a vertical line and a diagonal line, which represents the distance of the rocket from you when it's moving. Okay, step 2 is label all quantities and their rates of change. I label this as A, B, and C. So the front view, which is A, we need to find what is A prime, which is the answer for dA per dt. As can be seen here, it says 5,000 meters, which is A is 5,000 meters, because it says observation post, which is the front view. But what is A prime, which is the dA per dt? Since there is no time given, so the answer will be 0. Yes, the A prime is 0. And next we need to find the answer of B. What is B? B was also used dB per dt to find the B prime, which is the distance of B per time, and an altitude of 10,000 meters, which means B is 10,000. And also, it also says that the rate of 200 meters per second, so there's a dB per dt in the question, so B prime is 200. And next, let's find what is C, which is a diagonal line, which means the distance of the rocket moving from you. And in the question, it also says that how fast is the rocket moving away from you at this moment, which is the C. So what is C prime? This is what we need to find in this question. So we'll use the formula of A power of 2, B power of 2 equals to C power of 2. This is because this is a Pythagoras, so we need to use this formula. And we insert the numbers that we got, which is 5,000 in the power of 2 plus 10,000 power of 2 equals to C power of 2. But we need to use square root for C, and also the numbers beside it. So C is 5,000 square root of 5. That is the C that we found. And this is a step 3. We relate all quantities in the same equation. Since we already got all the numbers for A, B, C, and B prime, so we can use that to find what is C prime, the answer, for the distance between you and the moving rocket. So we'll use A power of 2 plus B power of 2 equals to C power of 2. This is the formula that we'll be going to use for step 4. For this, I will let Abdul Halim going to present.
Derivative of A squared is 2A, but because I'm differentiating with respect to time, I have to multiply by a factor of the derivative of A with respect to time. Likewise, the derivative of B squared is 2B times the derivative of B with respect to time. And that's equal to the derivative of the other side of the equation, 2C, times the derivative of C with respect to time. Now I'm going to abbreviate the derivative of A with respect to time as A prime. I will abbreviate the derivative of B with respect to time as B prime, and the derivative of C with respect to time as C prime. You will often see a derivative abbreviated in this way. Once you differentiate with respect to time the equation that related all of the quantities in the problem, you then use that derivative to answer the question. Way back in step 2, we identified all of the lengths of the sides in our right triangle diagram, as well as the rates of change of all of those sides. And at this point, we can simply substitute those into the derivative to answer the question. We're trying to find the value of c prime, so we're going to substitute all